All right. Thank you everyone for being here today. Um, like she said, I'm Sean Kruse. I'm the state source water protection coordinator for Nebraska. I'm also a licensed well drilling contractor, which is, if you know me, that's probably the capacity that you knew me from. Um, Today, we're going to be talking about engaging community water systems on source water protection, as well as strategies for implementing source water protection within those communities. Since I've taken on this new role, something that I've noticed working with water systems is that a lot, not all, but a lot of systems have a decent understanding of anthropogenic contamination. We know where it's coming from, or if not where, if it's non-point source, we have a better understanding of why it's in our groundwater or why it might have ended up in our groundwater. People, from what I've come to know, are a lot more likely to take action on something that they have a better understanding of. With naturally occurring inorganic chemicals, it can be harder to draw that conclusion because oftentimes the source might differ system to system. This makes it a lot harder to mobilize source water protection if we don't know that how, where, why. So today I wanted to focus the presentation a little bit more on IOCs and strategies that we're working on as a program to address this issue. Before we dig into those strategies, we're going to take a few minutes here to discuss a background of inorganic contaminants. So what are inorganic chemicals? These are contaminants that are naturally occurring in Nebraska's geological formations or soil profiles. The most commonly known is obviously more known for its anthropogenic sources, but nitrate nitrite is also an IOC. Studies have linked naturally occurring nitrate to below 1 milligram per liter. Concentrations above that are likely linked to human practices. However, many community water systems in Nebraska struggle with turbidity and aesthetic issues in their water as well. The likely causes of this are iron and manganese. An example that we've seen in the news recently is the West Point water system, if you guys have seen that. They are struggling with high manganese, which is causing aesthetic issues in their water. Manganese is not regulated, but it has an established secondary MCL, or maximum contaminant level, and health advisory levels. The EPA has not yet enforced a primary maximum contaminant level for manganese. The secondary maximum contaminant level is 0.05 milligrams per liter, which is when we're going to start seeing things such as aesthetic issues like discoloration. The lifetime health advisory is 0.3 milligrams per liter, and the acute health advisory is 1 milligram per liter. We can see on this map here where some very high manganese results came back in Nebraska, but right next to those results in the blue dots, we see an equal number of non-detects where there is 0 milligrams per liter detected. Some systems even have one well testing well above the lifetime health advisory level, and their other well is testing well below it. This makes it very challenging to engage communities on what they need to do to solve the problem because we can't give a general answer quite yet about where it's coming from. This is a conclusion we have to draw on a system by system basis based on the region that it's in. IOCs are also very challenging because the public is a lot more likely to notice something that affects the physical properties of their water that they can notice with their eyes. We're going to briefly discuss a few common issues with IOCs. These are also reasons why it can make source water protection and community water systems very confusing. Wells that are in close proximity to each other are under the influence of drawdown for nearby wells. This can affect varied concentrations in IOCs. Treatment plants are obviously a very expensive feat for community water systems to take on and may not be the complete answer to the problem. IOCs have a tendency to build up in pipes and slough off even after treatment for years to come. And of course, some IOCs are not regulated, such as iron and manganese, which causes problems because we don't have the authority to require action be taken. This is why we are working on developing these strategies, which we'll now cover in the next few slides. So our goal in the source water protection program is to engage communities in a way where we can better explain the problem and address this at a stage where it will have a beneficial impact. This stage that I'm referring to is early on in the well siting process. We want to ensure that we aren't allowing mistakes to be repeated now that we have extensive knowledge and data to make better choices. What we've started to work on is a toolbox that can provide educational information regarding key hydrogeological properties of the system's aquifer that could relate not just to siting a new well, but as we've discovered, potential IOCs. Some of this information includes the static water level, saturated sand thickness, bedrock geology, geological cross sections, which we'll see in the next slide, and profile information. We also include water quality analysis with this toolbox that we're working on because recent studies have shown that IOCs may be more mobile under the presence of additional contaminants. We are basing these toolboxes off of our existing databases, such as the Registered Wells database, formerly in the Department of Natural Resources, now under DWE, and the Groundwater Quality Clearinghouse. Up on the slide here, we can see images that were calculated from one of the trial runs of the toolbox that calculated the static water level as well as saturated sand thickness. We can see in the top graph, or the top figure that's up on that slide with the red and yellow, the areas that are in red are areas where there's increased saturated sand. We briefly talked about this with the last slide, but the main goal is to provide interpretations of existing data in a manner where a system can benefit from enhanced decision-making by developing those correlations before we get to a point where a new well has been installed. To clarify, the intent of these tools is to not explicitly cite the well for the community water system, but to provide that solid framework that they need for beginning the process and to address some of these things that need to be discussed before we drill a new well. In this diagram here is one of the cross sections, which might be a generous term. I prefer to use the term well plot because that is what it's doing here, is that it plots registered wells within the database. This allows for community water systems to observe recorded geological profiles and make these correlations based on the contamination that they might be seeing within their public water system well. The final part of the presentation, I'm going to touch on an existing program that we have within the Source Water Protection Program that we've been using to address some of these issues, and that's our Source Water Protection Program grant, which is a small grant program for community water systems serving populations 10,000 or less that might be experiencing financial hardship. These grants can go towards events in the well siting process, such as drilling test holes and test wells, or even contaminant source investigations to include IOCs. Some popular projects that we've been getting requests for are those things, as I just mentioned, that are key events in that well siting process, such as drilling test holes and test wells, as well as conducting aquifer pumping tests to establish the capacity of their future well or to conduct an aquifer quality analysis. We also receive a lot of requests to remove contaminant sources, such as the decommissioning of abandoned water wells. Last year, we funded a project with the intent of decommissioning up to 25 private wells within or near their wellhead protection area, as well as 2 of their municipal wells that were taken offline due to high selenium. And with that, I think I sped through that way too fast, but with that, we're now going to move on to questions.
Good stuff. Thank you, Sean. We do have plenty of time for questions, so please, any questions from the audience? Raja?
If you can go back to the slide with the parameters too. You said what might be the, or might be one or more controlling parameter. See where we have a high concentration, so some so you see that if you look at major iron, so where you see highest concentrations on these.
Are you referring to the state manganese map or the ones developed by the tools?
Tools.
So these aren't graphics of manganese explicitly, but hydrogeological properties that could be correlated. So saturated sand thickness and then static water level is the one that has the blues, greens, and reds. One of the ways that we've been exploring on what might be a connection is that increased levels of saturated sand thickness might provide a lower probability of having IOCs within your drinking water because you have more of a buffer between some of those consolidated aquifer formations that might be producing those contaminants.
Higher in the eastern side of the state compared to west.
From the data that we've received, it would appear that way. However, I think there's also a little bit of a challenge in addressing that information because there's less systems in western Nebraska, and so we inherently have less data from that region. But from the data that we've received, it's predominantly the higher concentrations are in eastern Nebraska. Yes.
Costs for treatment of water systems for iron and manganese.
As far as for individual treatment, aside from the existing systems that have treatments, we haven't assessed what that might look like. Something that we've started to have conversations on is regionalizing some water systems that might be under an administrative order, connect what the cost feasibility would be if rather than installing their own treatment plant versus interconnecting with a system that has an existing treatment plant. But other than that, I cannot give you specifics on what costs might be for a community water system to install a treatment plant.
You're talking about the different programs, USP program. Have you had a lot of interest? And then like what sort of barriers you seen with that?
Interest in the which specific program?
Like your programs for the communities that are approaching or exceeded the MCL.
We do see a lot of interest in that. And I think a lot of where that interest comes from is assistance in educating the board on what needs to happen to resolve the problem. And I think that's also one of the biggest barriers that we have too, is that the water operators are very involved in addressing the issue at hand, whereas their board might not be in complete understanding of what needs to be done. And so I think that's also a big barrier that we face, but also a lot of where the interest is gauged from, which is a key component of the toolboxes that we're working on developing, because the more resources that we have to explain these issues to individuals such as community board members, the more beneficial it is to us. Dr. Malkar?
So I have two questions. So about the protocol on get these samples, you filter them and then the analysis. And do you also do I-90 with or iron samples?
So for the data that's in the statewide manganese map, that was collected during a 2020 study that the agency conducted, which we're now working on processing the data from. Those were, I can't speak specifically on the study as the project managers are going through those processes. As far as the data for the tools, a lot of that information is extracted from the geological logs associated with the wells that are drilled, as well as some of those key properties that are featured in the Nebraska Groundwater Quality Clearinghouse. I have not done a correlation myself to areas of high manganese and then what those high nitrate concentrations might look like. However, I have seen several studies, one from USGS, where there were indications that high nitrate was an influence on the mobility of manganese. Does that answer your question?
Thanks.
Thank you.
All right, any other questions from the audience? Well, thank you very much.
Thank you, everyone.